Welcome to lecture number 63. In this lecture, we will study Y-connected source and a delta-connected load arrangement. In our last lecture, we studied that it's a recap of the last lecture. We studied that Z delta can be written as 3 times Zy, or Zy can be written as 1 over 3 times Z delta. Here we have a Y-connected source and a delta-connected load, whereas Z line is given to be 0 ohms for your convenience. Right. In order to solve this, there are many ways. Perhaps the simplest way is to convert this delta connected load into Y connected. Right. We know that in order to go to Y, we should divide each impedance of each branch by 3. So this is 10 plus J7.5 divided by 3. This and this, these two will also be the same. Right. So now we can solve it per phase to make calculations easier. So let's take phase A first, and the remaining would be found by symmetry. So this is 10 plus J7.5 divided by 3. This turns out to be 3.3 plus J2.5. The new impedance Cy. So we have converted Z delta into Cy. Cy is 1 by 3 times Z delta. So now we can find Ia by simply dividing by applying Ohm's law, and it turns out to be this much amperes. Ip and Ic can be found using symmetry. Ib should be 120 degrees lagging, Ic should be 240 degrees lagging. So now we have computed 3 line currents. The phase current, of course, would be divided by square root of 3, line current divided by square root of 3, and should be lagging by 30 degrees, minus 30, right? Similarly, IBC and ICA, the other two phase currents, can be found in a similar way, which is left as a homework for students. Right, we will continue studying three phase circuits. That's all for this lecture. Thank you.